Hey, 8th grade. I hope you had a great 3-day weekend. Today we're moving on to the last lesson in chapter 2, which means we'll be testing this week. Okay? The last section is 2.5, and we're going to go over types of linear equation solutions. So there's 3 different types. And this came straight from your book. It's on page 71. So if we go a little too fast, you can either pause it here or you can look in your book and copy it from there. So in algebra, this is what it looks like, where A is a number and X represents a variable, okay? So A equals B. So this is where a number is equal to a different number, right? So you would have you could pick anything here. 7 equals 40. That means that there's no solution that will make that true because 40 and 7 are not equal. So this is when you'll do a solution, you'll do an equation, and you end up with an answer that is not equal to the other side, which means there's no solution to that problem. We're going to do examples, okay? The second one is where X equals A. So if X is a variable, is equal to a number, right, like X equals 7, then that means there's one solution that makes it true, right? So only one value makes the equation true. 7. 7 is the only thing that makes that work. And then lastly, the third one is if when you solve the equation, you end up with 7 equals 7 on both sides of the equation, 7 on left and 7 on the right. That means there's an infinite number of values that make this true. That means you can put anything in for the X value, okay? And I'm gonna show you what all of these mean, but this is the table that came from your book. Okay, so let's start with some examples. Example 1. 2x minus 4 equals negative x minus 1. We have to solve for this first. Then, depending on whether our answer looks like a number equal to a different number, a number equal to a number, or an answer equal to itself, will determine how many solutions this equation has. So first, we're going to set this up just like we've been doing all chapter. So I'm going to draw my line through the equal sign, and then I'm going to start moving stuff around. So this is my smaller. I have a variable on both sides, so I'm going to move this one. So it's a negative x, so I'm going to add x. Whatever I do to one side, I have to do to the other. So I end up with 3x, and then if I bring down everything else, I have minus 4 equals negative 1 because my x's fell out. So now I'm going to move my number over. So I'm going to add 4 because I see minus 4. Negative 4 plus 4 is 0. If I add 4 to this side, to the right side, using the twin rule, I end up with 3x on the left is equal to 3 on the right. So then I divide by 3 to get the variable alone, and I get x is equal to 1. Okay? X is equal to 1. So this answer looks like this. Okay, so I'm going to put it on the outside over here. I'm going to be like example 1 in parentheses, right? So this is the one that it matches because it's showing the variable is equal to one number, which means there's only one solution. If I was to check this right now, if I put 1 in for x, then that's the only number that this problem would work for, right? If I put in 7 or 40 or any of the other numbers, positive or negative, it wouldn't be true. The answer wouldn't work, okay? So this one has one solution. The only solution is 1. All right, let's try a different one. 2x minus 4 is equal to 2 parentheses x minus 2. Okay, same thing. I'm going to draw my line down the equal sign. There's nothing to do on the left. I'm just going to bring it down, 2x minus 4. My first step is going to be on the right, and I'm going to distribute the 2 on the outside to get rid of the parentheses. So I've got 2 times x is 2x, and then I have 2 times negative 4, or 2 times negative 2 equals negative 4. So now I'm going to combine. So take away 2x on the left to move it over to the right. 2x minus 2x means no x's on this side. I just have a negative 4. And then 2x minus 2x on this side falls out also. And I'm left with negative 4 equals negative 4. This is an example of this last one where you get the same number on both sides. So I'm going to put in small parentheses, example 2. Example 2. Because I have infinitely a number of solutions. I can put any number in here for x, right? Because it's on both sides. So if I say I want x to be 12, 2 times 12 minus 4 on this side is going to get the same on the right if I put in 12 here. If I put in 20, if I put in a negative number, any number, because we ended up with the same answer on both sides, will work. This example, okay, for this equation is infinity because any number will work. All right. Last one. I'm sure you can guess what this one's going to look like, but let's go ahead and solve it. It's going to be really important that you guys are solving these slowly. Like, you don't want any careless mistakes, because in example 2, we have 2x minus 4, which is going to be the same in example 3, 2x minus 4 equals, and then we have 2 parentheses x minus 2. In this one, we have 2 parentheses x plus 1. There's only one small change. So if you make a silly, careless mistake, like with your signs, you may end up with the wrong answer at the end, okay? Which means then you'll be telling me the wrong solution. So please, like, go slow and try to catch all your mistakes, okay? Double check your work. On the left, 2x minus 4, there's nothing to do. On the right, we're going to distribute the 2, and we end up with 2x and then plus, oh, sorry, it was 2. Was it? No, it was 1. It was 1. So the sign is different and just the last number is different. 2x plus 1 is 2. Okay, so I'm going to move my x over to the other side. 2x minus 2x falls out. So then I do it on the left using the twin rule. Whatever I do on the right, I do on the left. That also falls out. And I'm left with a negative 4 is equal to a positive 2. This is my final answer. This is never true. Negative 4 is not equal to 2, which means there's no solution that will make this problem true. So this is an example like the first one. A equals B, where both those are numbers. Negative 4 is equal to 2. It's not. It's not equal to 2. So the answer is no solution. Okay. If you have any questions, come see me at office hours. Maybe go through the examples again. You can rewatch the video. You can look at the examples in your book. I took these straight from them. Okay? Page 71 is what we were on. For homework tonight, we are going to be on page 73, and we are going to be doing, let's do numbers 6 through 13. All. Okay? Again, if you have any questions, come see me. Thanks, guys.